Section 5.6, inverse trig functions, and then we're going to take the derivative of them. So start with trig functions. We know that most trig functions don't pass the horizontal line test, so that means that their inverses are not functions, unless we restrict their domains and their ranges. So here's the graph of sine x. You can see that if we pass a horizontal line through this, it will hit the graph in more than one place. So then the inverse of it would not be a function. But if we just look at the domain like from 0 to 2 pi, not including the endpoints, okay, that's not going to help either, because we'll have here pass it, it'll cross twice. So where should we have it? Where should we restrict the domain? Maybe pi over 2 to 3 pi over 2. Then we would have one function. It would be a horizontal line, so it would be a one-to-one function. So mathematicians have done all the deciding for us of which domains we're going to restrict. So here's the inverse sign. We're going from -1 to 1. That's what they've decided to restrict the domain to. And this notation, sine to the -1 power, is called the inverse sign. It does not mean 1 over sine, which is normally what we use for a negative exponent. So inverse sine does not equal 1 over sine. That is totally different, okay? You don't even want to write it, because they'll put that in your mind. Inverse sine means the inverse of the sine function, so it's like undoing a square root or undoing adding. It's undoing a sine. Another way to write it is arc sine, and that means inverse sine also. You'll see both ways. The domain is -1 to 1, including those endpoints, and then the range then would go -pi over 2 to pi over 2. So remember, for inverses, the domain and range switch. So if the original function is sine, so that domain is -pi over 2 to pi over 2. So let's go back to that picture. If we restrict the domain from -pi over 2 to pi over 2, that's the part of the sine graph we're finding the inverse of. And if you remember, an inverse is reflected over the line y equals x. So if you picture this line, y equals x, and then the purple line being reflected over it, that's how you get this graph of the inverse sign. Okay? So the domain and range of our original function are going -1 to 1 for our range. So the range, notice it's up here at 1 and down here -1. That becomes the domain for our inverse sine function. -1 to 1. And the range is -pi over 2, which is about here, to here, +pi over 2. So inverses, remember, the domain and range switch, and this restricted part of the graph does make a function, because the vertical line test would never cross the line more than once. Cosine. Arc cosine is restricted from -1 to 1. The range is 0 to pi. Tangent. The domain is all reals, and the range is pi over 2 to -pi over 2. So basically we're just looking at one branch of the tangent graph. Arcsecant. The domain is all values of x except -1 and 1. So everything except values in between -1 and 1. So nothing in here, because this goes up forever and this goes down forever, but nothing in between. And the range is 0 to pi, and so from here to here, but not pi over 2. So it's pretty weird. Arcsecant's a pretty weird one, and so is arccosecant. It goes in positive direction and negative x direction, but nothing in the middle between -1 and 1, and the range -pi over 2 to pi over 2, but nothing at 0. So pretty weird domains and ranges for those two. Arccotangent, the domain is all reals. The range is 0 to pi. All right? So remember what inverses do. They undo each other. So the sine of arcsine of x would just be x. Or you could write sine of inverse sine of x is just x. They undo each other. And vice versa, arcsine of sine of x for all trig functions in their little domains, whatever part of the graph we're looking at. So if we have like tangent of arctangent of x to the third power, that would just equal x to the third power because they undo each other. Okay, that's the only way to get something out of a trig function is to do the opposite of the trig function. So if we're trying to get something out of the sine function, you know, if we have an equation like this and we want to get this x squared out of the sine function, we have to do inverse sine of both sides to get these two to cancel out, and then we'll just have x squared equals whatever inverse sine of 4 is, if 4 is even in the domain of sine, or inverse sine. All right, so we're asked to evaluate these without using a calculator. Think about what it means. Usually we would say sine of x equals 0. So this is what the answer is for the angle that we don't know. So this is asking for the angle. The inverse sine will always be asking for an angle, and the 0, or whatever number we have here, is the answer of the sine of that angle. So we're trying to find the angle that has a sine of 0. Like here, the ordered pair is 1, 0. Notice the sine is 0. So what angle is this? It's 0. So arcsine of 0 equals 0. Is there anywhere else in our circle where our sine will be 0? What about here? Negative 1, 0. So also at pi. However, is pi in the domain of arcsine? So let's go back and look at the domain of arcsine. Domain is negative 1 to 1. Range is negative pi over 2 to pi over 2. So our answer of pi would not be in our range. I'm sorry, 0 is in the domain, that's fine, but the range would not include pi because our range goes from negative pi over 2 to pi over 2. So 0 is the only answer. Let's think about arcsine of square root of 3 over 2. The easiest way to do this one, I think, is to make a triangle. Pick an angle, like let's say we're doing this angle. We're trying to find that angle, so it equals the angle that we're trying to find. Okay? Remember, arcsine of something always asks you for the angle that if we take the sine of it, we would get square root of 3 over 2. Well, remember what sine is with SOHCAHTOA. Sine is opposite over hypotenuse. So this must have been the opposite, and this must have been the hypotenuse. So let's make our triangle reflect that. Opposite is over here, so that was square root of 3. Hypotenuse is here, so that's a 2. So now I need to know what angle would produce this kind of triangle. So if we have these two sides, and then we can use the Pythagorean theorem to figure out that this side is a 1. Some of you might know that that triangle would be a 30, 60, 90 triangle. So in a 30, 60, 90 triangle, which side is the bigger angle? Actually, what I like to do is think about it in my unit circle. So I always make sure my hypotenuse is 1. And if I'm going from this angle, opposite over hypotenuse, I wouldn't do this. I would do this whole thing is opposite and then over 1 for hypotenuse. So opposite and hypotenuse, so I know that's going to be 1/2. So in my triangle, this is the longer side, this is the shorter side. So of the 30, 60, 90 triangle, I know this is my bigger angle because it's across from my longer side. And this is the smaller angle because it's across from the shorter side. So whichever way you like to think about it, I've been teaching it this way this year, but you may have learned your triangles based on this. So you should know those major angles and the inverses of them, be able to figure them out at least, without a calculator. Let's try this one. Arc cotangent of -1. So arc cotangent. I know that tangent is sine over cosine. So cotangent is cosine over sine. Okay? And I know that the triangle that gives you tangents and cotangents is the triangle that has two sides that are equal. if they divide and they equal -1, then it must be two sides that are the same. So we're talking about the square root of 2 over 2. But since it's negative, we should flip it to be in the other quadrant, because we want one of them to be negative and one of them to be positive. So this one would be our negative square root of 2 over 2, and this would be our positive square root of 2 over 2. So now arc cotangent from this angle, opposite over adjacent. That's TOA. We want adjacent over opposite, right? For cotangent, adjacent over opposite gives us a -1. So then we know the angle that must correspond to it must have been, this one's 45, so based on our unit circle, if this is 0, what's that? Because this whole thing all the way to pi, or 180, depends if you're doing degrees or radians. 180 minus 45, or you can do pi minus 45 degrees would be pi over 4. So get your common denominator, it's 3 pi over 4. Or would it be this one down here? Let's think about that, because this would be a positive square root of 2 over 2, and this would be a negative square root of 2 over 2. That would also give us a -1, and that angle would be negative pi over 4. Which of these is in the domain of, or in the range of cotangent? Which one could be a possible answer for cotangent? So let's go back to cotangent. We want our answer to be between 0 and pi. So negative pi over 2 doesn't, or negative pi over 4 does not work. It's not in our domain or our range. So 3 pi over 4 is the answer we want. How about arctan of square root of 3? So tangent is opposite over adjacent. How are we going to think about a square root of 3? From this angle, we know that's 1, so opposite over adjacent. That must be square root of 3 over 2 here, and 1/2 here, because square root of 3 over 2 divided by 1/2 is the same as square root of 3 over 2 times the reciprocal, which equals square root of 3. So if that's the square root of 3 over 2, and that's 1/2, opposite over adjacent gives us square root of 3. So we've set up the triangle correctly. And then we know that this is the long side and that's the short side, so that must be 60 degrees. Or if you're doing radians, pi over 3. All right, these ones are actually a little bit easier. If you do a trig function of an inverse trig function, we're going to set up our triangle using exactly the 4/5. So this part is asking for the angle, whatever degrees or radians, so let's say it's this one. Arc sine is opposite over hypotenuse, so we know the 4 is over here and the 5 is over here. And now that we've set up our triangle, from this angle I want tangent of that angle. So tangent is opposite over adjacent, so I want 4 over adjacent, so I better figure out that side. So a squared plus b squared equals c squared. A squared equals 25 minus 16, which is 9. So square root of 9 is 3. So we know a is 3. So tangent of that angle is opposite over adjacent, so that would equal 4/3. So you use this part to set up the triangle, and then you use this to decide which sides of the triangle you want. So let's try that again. Arc sine 5 over 13. Sine is opposite over hypotenuse. I want cosine of that angle. That's that angle. Cosine is adjacent over hypotenuse, so I need this side. So 13 squared minus 5 squared. 169 minus 25. 144, so that's 12. So adjacent over hypotenuse is 12 over 13. For those you don't have to memorize anything or try to figure out which angle it matches, you just plug in the numbers based on this and then use this to decide which sides you're going to use. Sometimes they're going to ask you to write the expression in algebraic form. So it's the same idea we just did, but they're using letters. So set up a triangle. Again, this part is an angle. Let's say it's this angle. Arctan, tan is opposite over adjacent. So we don't have a fraction here, so let's say this is the opposite and this is the adjacent. So opposite over adjacent. We want secant of that angle. Well, secant is 1 over cosine. Cosine is adjacent over hypotenuse. So 1 over cosine is hypotenuse over adjacent. So secant of x, or secant of my angle, will be hypotenuse over adjacent. So I need hypotenuse over adjacent. So I better find the hypotenuse. So I have a squared plus b squared. Remember to square the whole thing, equals my hypotenuse, c squared. So 1 plus 9x squared equals c squared. So c is the square root of 9x squared plus 1. So now I need hypotenuse over adjacent, so that's this over 1. So that would equal the square root of 9x squared plus 1 over 1. Cosine of arcsine of 3x. So we're going to set up our triangle the same way. Sine of 3x. So sine is opposite over hypotenuse. Opposite over hypotenuse. So now I have to find this side. A squared plus b squared equals c squared. So a squared plus 9x squared equals 1. A squared equals 1 minus 9x squared. So a is the square root of 1 minus 9x squared. So that's my angle. Arcsine is opposite over hypotenuse, and I want the cosine of that. So I need adjacent over hypotenuse. So that's going to equal the square root of 1 minus 9x squared over 1. You're also going to be asked on your homework to solve equations. To undo the arctan to get at that x, we're going to do tangent of both sides. So those cancel out, and we'll have 2x minus 3 equals tangent of pi over 4. Pi over 4 is our 45-degree angle. Square root of 2 over 2 on each side. Tangent is opposite over adjacent. So square root of 2 over 2 divided by square root of 2 over 2 is 1. Add 3 to both sides. You get 4. X is 2. And there's your homework.